Hi, Vicky.
Hi, Shane.
If you could ask one famous person, frankly, dead or alive, one question, there's a lot of caveats here. Who would that person be?
Okay.
And what question would you ask them?
I'm really interested to see how this fits into the episode.
I mean, frankly, it might not, but
Okay,
prompts are hard.
all right.
And so here we go. So
Okay.
what you got?
Okay. So I guess I've actually been waiting for someone to ask me this question in a public venue
Yes.
my whole life.
Got
Okay.
it.
Macaulay Culkin,
Okay.
and if he will marry me.
Oh my gosh.
Yeah.
I mean, my first
So,
question is why? I
Yeah.
feel like that's too general, but like how have you enjoyed Macaulay Culkin since Home Alone era?
Since my youth.
Since your youth?
Since my youth. So, yeah, Home Alone, just everything he did when he was a kid. I was also a little kid and just super in love with him. Like, I feel like he was my first crush ever.
Oh my
And I've sort
goodness.
of followed along.
This brings me so
Um,
much joy.
yeah. No, yeah. So, Macaulay Culkin, will you marry me?
Oh, this is so great.
Wait, so, yeah. Anyway,
Okay.
so that's really embarrassing.
Okay. So
Yeah, what's yours?
mine's nerdy, but we said we were going to go with our first gut.
Yeah.
My question would be, I would ask Kathleen Kennedy, who is in charge of Lucasfilm, the studio that makes Star Wars. I would ask Kathleen Kennedy why she decided not to go with Colin Trevorrow, who is a director, for the 9th Star Wars movie, like the new ones, and instead went with J.J. Abrams, who made possibly the worst Star Wars movie ever made. It hurts my soul. I was so disappointed. I don't care if this is a hot take. I need to know. I've seen the
Don't
script
at
for this
me.
movie. It is so good. But they got scared and they made a movie that was just not very good.
Oh,
I said it.
I know. I love your hands are like thrown up in the air.
I said it.
You said it.
I laid it down.
I really love how we like probably could have asked a really important person a really important question that could like shape the future of the planet.
No, this is what's important to us. These are our stakes. We should just live with it. Science is fascinating. But don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon.
And I'm Vicky Thompson.
And this is Third Pod from the Sun. So that got a little out of control. And these are questions that we will likely never find the answers to, though I want to know about Macaulay Culkin.
Yeah.
But to get some answers, hopefully, to some questions we do have, I'm going to bring in producer Katrina Jackson. Hi, Katrina.
Hi, Shane. And just to be clear, I don't have all the answers, just more questions, especially the Macaulay Culkin one. I mean, isn't he in a long-term relationship with Brenda Song?
I mean, Vicky's also married. So.
I'm married.
Okay.
Yeah. So,
all right. No problem.
So hopefully we never get an answer.
But yeah, I have a lot of questions.
But I assume you have questions that are more relevant to this episode.
I do,
right?
yeah. Yeah, so when Shane asked if I had any ideas for an episode with a fire theme, I started trying to think if there was any possible connection to planetary science and astrobiology, just because I tend to do that. But of course, what are types of things that fire usually burns?
Well, what doesn't it burn? Wood.
I think wood, right?
Yeah, burns wood.
Right. Yeah, but if you think about it, mostly all that burns is living things or things that were once living. So I started wondering, is life required for fire to happen? And are there any other planets where fire could happen?
So I don't know. My face. I don't know the answer to that. Though the framing's a little interesting. Like, is life required to burn something?
Yeah, and I wasn't sure either. And Back in college, I had taken several planetary science classes, including a few astrobiology courses, but I don't remember the topic of fire ever even coming up. And the internet wasn't giving me a whole lot of information, so to try to help illuminate this whole planets on fire issue, I talked with an astrobiologist at the Universidad Nacional Autónoma de México in Mexico City.
I am Antígona Segura Peralta, and I am an astrobiologist in Mexico.
So you all have done a few episodes on fire now, so I assume you know at this point generally how fire works?
I'm punting that right to Shane.
I don't know how fire works. You need some sort of fuel, right? There's like an ignition.
Mm-hmm.
I'm sure something else.
Yeah.
What's the other thing?
There's the fire triangle with heat, fuel, and oxygen. The three things you need for fire.
Okay.
And so I started with asking Antígona about what could be some potential sources for these three elements of fire, particularly fuel and oxygen, on other planets.
Well, yes, that's where that becomes very interesting, because usually we are thinking like the fuel, it's, for example, piece of wood, right? Or a gasoline that is created by people. But there was, for example, oil that it doesn't need the presence of persons, but it does need life in order to be created, right? So in other planets, we may think about these planets where you don't have any life at all, but you have oxygen and hydrogen enough to start self-reaction combustion, a self-combustion process. So basically, you don't need really the intervention of any life to start the combustion, but these scenarios of which kind of planets may have the conditions to start combustion by themselves, we don't know how common they are, right? Because for now, what we know about the atmospheres of exoplanets, planets around other stars, is very limited. So there are some models that shows that for some planets, for example, if the light of the star, the X-ray and UV light from the star is high enough, then the water in the atmosphere and in the surface of the water in the surface evaporates and goes into the atmosphere, and then when it goes into the atmosphere, it gets splitted, and then you have hydrogen and oxygen that can get high enough. I mean, if you vaporize an entire ocean, it would be a lot of oxygen and hydrogen. We are talking about like 90 times the atmosphere of Earth, right? So that kind of atmosphere can combust by itself, like just, right?
Okay. So that's one potential source of fire, is if you have like a whole ocean evaporate and you have a whole bunch of hydrogen and a whole bunch of oxygen in an atmosphere. What would that look like to have that combustion? Would it be like the whole atmosphere on fire, or just like little bits of explosions? Or do you have any idea?
Well, that's where we need a lot of imagination, because we haven't. I mean, usually what you do when you are modeling this, there was this group in Germany led by Lee Grenfell, who did these models. But basically, these models are 1D models. That means that they consider the whole atmosphere is just one line, right? So over there, you see how much there is of a lot of compounds, and then you say, based on what you know from experiments, if you reach this threshold to start combustion. But then, I mean, to do a 3D planet model and then having the whole circulation and all the things that you have to consider, that's more complex. So we don't really know how a planet like this would look like. It should be like very beautiful. And I suppose the temperature would be very high, but not sure. I'm going to leave that to the imagination of the people who is hearing us.
I just can't I can't picture this. I can't imagine an entire atmosphere on fire. That's just fire everywhere.
Yeah, I was pretty stunned at this concept of an atmosphere literally exploding or self-combusting. And I had completely missed this paper when I was preparing for the interview, this study that Antígona was talking about by this group of German scientists. I had been using search terms like fire and astrobiology or fire and exoplanets, but maybe if I had searched for combustion instead of fire, I might have found it. But I did look up the paper after the interview. It's from 2018 and is titled Limitation of Atmospheric Composition by Combustion Explosion in Exoplanetary Atmospheres. And it is fascinating.
I can't believe that an atmosphere on fire would be a real thing.
Yeah, well, it's theoretical at this point, but they really do have various figures in the paper showing possible scenarios where an atmosphere could combust.
That is so cool. Or say it with me now, hot.
Hot. Right. Yeah.
But on bump.
And just a brief side note, another thing that I found out when I was looking at this paper is that one of the co-authors, the second author of the paper, she actually ran for president of Germany earlier this year. Yeah.
Really?
Like how many
Fascinating.
astronomer politicians do you know?
We need more science politicians, like, especially, I mean, this is very irrelevant because yesterday, as of recording this, was elections here in the States.
Right.
So yeah, I think that's great. More scientists in politics.
Yes.
To be honest, I didn't even know Germany had a president. I was aware of the chancellor. But yeah, I was just learning all sorts of stuff putting together this podcast episode.
Wow.
But so back to fires on planets. I still had a lot more questions for Antígona. So, thinking about Earth, our planet, back before life started to evolve, do you think it would have been possible on Earth for there to have been fire before life?
That was a very interesting question because I never thought about it. And for some time, there was no life. Then there was life, but still nitrogen and CO2. And then life produced the oxygen. And then that oxygen was the perfect gas for combustion. But before that, we didn't have the oxygen to start the fire. So I would dare to say that there was no fire in early Earth before. I mean, there were volcanoes that had a lot of energy, things like that.
Yeah, we think of the early Earth being kind of a hot, molten place, but probably not actually fire. Interesting. Yeah, and then, of course, as life evolved, especially once you got, plants on land and stuff, wildfire has become, such an important part of the ecosystem that there's kind of a big relationship now between fire and life. Have you ever thought about whether that relationship between fire and life might be intrinsic in some way? Like, do you think it would be possible for life to continue to evolve without fire? Or do you think about this at all, about the relationship between fire and life?
No, I never thought about fire, actually, unless you are in the lab and you have to be careful of it. But yeah, it was very interesting when I received the question because I think, well, that's already an interesting question and I would like to think about it. So I've been thinking about it. I mean, the problem with life, when we hypothesize things about life, is that life on Earth is just an example, and it's the result of all these little things that happen during the Earth's history. So it's hard to know how in other planet could develop. Right? It's something that we cannot. But maybe fire is something that happens in other planets that have carbon-based life. I can think that may happen.
Okay. Yes. I get what you're saying. It's hard to extrapolate to life on other planets because we only have our one example. So we don't know of any other planets or planetary bodies in our solar system that could have fire, correct?
That's right. We don't know about anyone.
Which has been part of the struggle of finding someone from planetary science and astrobiology who could talk on this. Because that's it's just not something that we're observing, but it's interesting to think about.
I was brave enough to accept.
And so, this is all a little bit of extrapolation, but if there were an exoplanet that did have fire on it, do you think there would be any observable chemical signatures in its atmosphere that we would be able to tell that something was burning?
Well, sadly, combustion produces water. So that's that. Now, maybe you can see water and a hot planet, and you could say, like, is this planet combusting? Because you detect like high amounts of oxygen and hydrogen, something like that. When hydrogen is very hard to detect in exoplanetary atmospheres, it would be very, very hard to say something like that.
What about like large wildfires on the ground? If it was an Earth-like planet that had biology and life and it frequently had fires, would we be able to detect that at all?
Well, I was thinking like maybe ashes could be the atmosphere could start to could be dark because of ashes, for example. But when planetary atmospheres are dark, what we see is basically nothing. So if you have something like ashes, what is going to have is that instead of the wiggles you usually have from the planet, you get a flat line. And basically you can say, well, there is a lot of hydrocarbons or something else, like it's producing hazes or clouds that are blocking our view from the planet. But we don't know what it is because a cloud, hazes, ashes, they would produce a flat spectrum. So I think there would be no way to know that this planet is on fire.
So even if a planet out there around another star did have fire, we probably wouldn't know about it.
Yeah, that might be the case, according to Antígona.
And also, none of the other places in our solar system have fire, like none of the other planets or, I guess, other celestial objects, whatever, either now or points in the past.
Yep, that's as far as we know.
And even on Earth, there were large portions of history when fire probably couldn't have existed.
Yeah, I imagine so, right? Because either there wasn't enough atmospheric oxygen, which we learned is oxygen is one of the things you need for fire, at least the way we understand it, which actually didn't exist in our quantities until life started creating oxygen, or because there wasn't much fuel, which is what you need, until life evolved as well.
Yeah, and I think that's so interesting to think about because fire is so much a part of our lives as humans. It's how we cook our food. It's how we have heat. It's what keeps the ecosystem of our forests and our grasslands in balance. But it sounds like we might never be able to observe fire burning anywhere outside of Earth, unless it's somewhere that humans have brought oxygen and fuel.
That makes Earth feel kind of special in that way, but also maybe that also feels sad and kind of lonely somehow. I don't know.
We're exceptional, Vicky.
We're so exceptional.
Okay, yeah, and to not. But there might not be fire on other planets that we can see or study. But there's still some pretty interesting hot and glowy sort of phenomenon throughout the solar system, right?
Oh, yeah, for sure. Volcanoes, lightning, volcanic lightning.
There's volcanic lightning on other planets?
Yeah, apparently early Mars could have had volcanic lightning, and that's actually what Antígona studied for her PhD dissertation, was the possibility of volcanic lightning being an energy source for the origin of life on Mars.
Oh,
I've got to hear more about this.
Well, basically, we are looking for any source of energy that could could start the first chemical reactions to initiate the process of life. So first you start from nitrogen and methane and hydrogen, carbon dioxide. And from that, with sources of energy, you split these molecules and create new molecules that are larger, and then those molecules are again reacting and then create larger molecules, and then suddenly you have a cell, right? A living being. It's not as easy as I just said it, but what I studied in my PhD in the lab with Rafael Navarro Gonzalez here in the National University in Mexico is basically to reproduce what we thought there was volcanic gases and some ashes, and then we use a laser, and with this laser we created a plasma, which is this very hot gas, which is produced when you have a lining. So basically we reproduce all the chemistry that happens during lining in the presence of these volcanic ashes and the volcanic gases. And what we found is that we could produce a hydrogen cyanide, HCN, hydrogen, carbon, and nitrogen. Altogether, it's one molecule. And this molecule is the point of a start from a lot of molecules that are relevant for the starting of life on Earth. So we don't know if that would be in other planets, but at least we found that this molecule could be produced in volcanic eruptions on Mars, early Mars, when there was water on Mars. There is water on Mars now, but it's just frozen. When there was liquid water on the surface of Mars, and there was a lot of volcanoes. Now all of that is gone, the liquid water, and the volcanoes are there, but they are just dead. So it's a possibility.
Yeah, and so I'm not sure if everyone even realizes that volcanic lightning is a thing on Earth. Can you describe a little bit just what that is and what that looks like?
Oh, yes, it looks beautiful. Search the videos in YouTube. Basically, what happens is that you need something that is called an explosive eruption. So when that happens, a lot of ashes are produced, but very quickly. So these ashes are electrically charged, and then they produce the lightning. So you have this huge. So let's imagine you have this volcano like in the middle of the sea or in an island, and this volcano creates all these ashes, and so you have this huge cloud of ashes, very, very dark ashes, and then in there you'll see all the lightning, and it's not just one, it's just starts happening like it's just beautiful. It's beautiful to see. So, well, I think it's beautiful. So you should look for the images. They are beautiful.
So you think the same phenomenon could have been happening on early Mars back when the volcanoes were active, having a bunch of lightning in the ashes from the volcanic explosion. Do you think this sort of volcanic lightning could happen on, for example, Io is the most volcanically active body in our solar system. But I don't know, are those volcanoes explosive? Would that produce the ash that you need for this lightning?
No, because there is no water.
Right, okay.
Yeah, the surface is right now covered with sulfur compounds. If that happened in Io, we could see it. So I am saying that it's not happening because we haven't seen it.
Vicky, have you ever seen volcanic lightning? Not in maybe in real life, but pictures or videos or anything like that.
Yeah, I've seen it. Obviously on the internet. It's amazing. It's really intense.
Yeah, AGU, to say good things about AGU, actually put out a press release with some amazing videos and images a few years back, I believe, that got a lot of coverage and uptick in pop culture. It's pretty wild, though. I can't imagine kind of transposing that onto the surface of Mars. Like, take volcanic lightning, but on Mars.
So what was the part about Io? That's one of the moons of Jupiter, right?
Yeah, Io is one of the 4 big moons of Jupiter, and it's one of the coolest looking places in our solar system because it's incredibly volcanically active. There's constantly lava flowing on its surface, but as Antígona said, Io's volcanoes don't have water, so they don't have that explosive type of eruptions needed to make giant ash clouds where you would have lightning.
I mean, it still sounds like an awesome place.
The whole field of astrobiology sounds really awesome and fascinating, and I'd be interested to hear Antigona's thoughts on what she finds most exciting about astrobiology.
Well, I am very excited that we are in this moment in the human history when we have the tools to answer some of these questions. For the first time, we have telescopes that can detect exoplanets. That's the first thing. And then the second thing is that we will have these instruments that are going to be able to observe the atmospheres of exoplanets. And in some of those atmospheres, we may have enough information to know if a planet is habitable or if the planet has life, which is, those are 2 different things because, it's like a house, right? The house can have all the services and everything, water, electricity, and everything. Nobody could live there. So just habitable, to have atmosphere, water, or maybe some features that tell us that the planet actually has some kind of life changing the atmosphere. Mm-hmm. So this is the first time that we can do it. So I am very excited because we can answer the question, are we alone?
Yeah, lots of instruments have come online, and a bunch more missions are in the pipeline. So yeah, that's pretty exciting time to be in this field. So how did you get into astrobiology?
Well, basically, I was in love of astronomy. I love stars, and I was very amazed by life, right? It was like, the fact that there were like insects that they could move and they could organize themselves. And then the fact that I knew that I was a living being, it was such a mystery for me that it was very exciting. So I wanted to be a biologist or an astronomer, but then I didn't have I didn't have a way to choose. And then there was Cosmos by Carl Sagan, that it was aired here in Mexico in Channel 5. And then my father bought me the book, and I was just amazed about something called exobiology that brought together biology and astronomy. And then I learned geology too, to understand if there was life out there and how life formed. And so I said I want to be an exobiologist. And after that, it was just looking for my path into astrobiology.
So you've wanted to get into this field ever since you were a kid, and seeing Carl Sagan and Cosmos, that's pretty cool. What have been some challenging things in your career?
Oof. Well, to look for a job in science is hard. Any science, right? It's just like any science, and I would say any country. You have to think that you should go anywhere in the world, but it's not really anywhere. Basically, we have Europe and US where there are more jobs, but then you may or not stay there. And I wanted to come back to my country, and I was very lucky actually to have a job in my country and in this university, where this is the largest university in Latin America, the National University of Mexico. But yes, one of the things was to find a job. And of course, there are some things that, when we think about the challenges, we usually think like the academic environment and things like that. But then there is all these things that happen in your life that affect your academic life. You live in this world, right? It's not like usually we think like scientists is like these persons that have almost no feelings. So basically, being a woman in my country and in other places, it is like you have to think about so many things that is just exhausting, right? And it takes a lot of energy and time to fight the people there are so many aggressions of the levels of aggression could be very low or very high. So all these things are things that, they become huge challenges because you cannot do your work if your mind is not at peace. So those kind of things are very hard. And so eventually some people, I did it. I overcome some of those challenges, but many others don't. So it's a real problem.
Yeah, and that's such a shame because listening to you, you've been so excited about the science, and it's just such an exciting thing to study, but so incredibly difficult in many ways. As a woman in Mexico, and all these different just things that you have to overcome. And yeah, it'd be great if science were a more welcoming place.
Oh yes. And then there is English, I know I haven't been invited some places because my English is not very good. And that's something, the people in Mexico who has a very good English is people who studied in private schools that have very good teachers in English. And I was at public school all my life. So basically the English I have is because my mother decided that I should go to a private school to learn a little bit of English. But it has been like a problem, for example, for me in science, because I get nervous because I know I don't have a perfect pronunciation. And then, as I say, there have been opportunities for me that I lost just because of my English. And I don't have time to improve it because I have so full of things to do. I have students.
I know she said she was nervous about it, but I think Antigona's English sounds great.
Yeah, and I wish I could speak Spanish better. I took 4 years of Spanish and 4 years of German, and I can't speak either language. It's awful.
That's the same for me.
Vicky, you can't. I can't speak any other language. I've been doing Duolingo for the better part of a year, and I took a trip to South America earlier this year just so I can get around. But basically, I've just been cheating on Duolingo because I just keep repeating the same lessons every day so that I keep my streak up. So
just to satisfy the notifications.
Yeah, my stats look a lot better than they actually are. But I think it's always so impressive when people are both super smart and knowledgeable and able to communicate in another language.
Yeah.
And I know that I very much appreciate that so much of science is communicated in English because that's super convenient for me. But of course, that can be a huge barrier for a lot of other people.
Yeah, language, nationality, and sexism, so many other obstacles can make science and geophysics a really difficult place.
And that's just scratching the surface of some of the challenges. And no one should have to persevere through so many obstacles. It should not be like that, but Antígona has, and she's been able to do something that she really loves.
I enjoy when I understand something. When we discovered, for example, what was going on with the atmospheres in planets around low mass stars. So the stars have different masses, and the planets I study is planets that are around very low mass stars, M dwarfs or red dwarfs, because they look red, right? So we didn't understand why there was so much methane on those planets. So I was trying to think about it, and I was working back then with James Casting in that time. So we were thinking together, and suddenly it's okay, you have more OH here than here, and then that's why methane is not being destroyed in the planets around. And that oh wow, yes, this is a solution. It was something and nobody thought about it before, and so that was a very happy moment for me.
Yeah, being able to figure out something that's a whole atmosphere on another planet, that sounds pretty cool to be able to to figure out those types of problems. So we have just a few minutes left. Is there anything else you'd like to share, or any of the questions that you'd like to go back to?
maybe the only thing I would say is that we haven't found a planet that is habitable for humans, and we are not looking for it, right? So that's very important to know. We are not searching for a planet just to throw this away and then go to other place. That's not going to happen. So this is the only habitable planet for humans, and it's getting hot because the human activity. So we humans are changing our planet in a way that is becoming a place that is not habitable for us, right? Because it's going to be habitable for other kinds of living beings. Don't worry about that. Life on Earth is going to continue without us, even if we hit the planet or we contaminate with metals or with whatever we put into the water. There will be living beings that are going to be very happy with that. But for us, it's a problem. So just a reminder of that this is not to search a planet to go away when this one is not habitable for humans anymore.
Yes, I hear you. Earth is by far the most habitable place for humans, and we need to keep it that way.
Yes. Sometimes people ask me, like, where do you like to go? I like nowhere. I like Earth. So I'll stay here. Thank you.
A now tired trope that I fed into for a long time is that I don't like space. I've mostly changed my tune on that one. I think space is super neat, frankly, but I'm with Antígona. We can live here. I am cool staying here on Earth. Good for me.
Yeah, and Earth is extra special since it's apparently the only place around where we can have fire. So who knew that?
Yeah, honestly, before Katrina pitched this, I had literally never thought about fire on other planets. And I got to thank you, Katrina, for constantly forcing me to think about space in a positive way.
Well, I'm sure I can also make you think about space in a negative way, just having around long enough.
You don't need to take that as a challenge. We can keep the positive side of things. All right. Well, with that is all from Third Pod from the Sun.
Thanks so much to Katrina for bringing us this story and to Antígona for sharing her work with us.
This episode was produced by Katrina with audio engineering from Colin Warren. Artwork by Jay Steiner.
We'd love to hear your thoughts on the podcast. Please rate and review us, and you can find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week. Heat, fuel, oxygen. Yeah, I guess that makes sense. I guess I think
heat would be the. I was like,
heat's kind of the ignition. I think in my mind, I thought of oxygen and fuel as being the same thing, but I guess not.
But the fuel would be like something to burn.
Yeah, it's like wood or
like
paper
wood or whatever. Yeah, but I guess you don't need a spark or like ignition. It could just be like heat that builds up, right?
Well, the spark is often from friction, or it could be from like.
What about like the magnifying glass fire?
Like, that's what I was thinking of. Right.
Okay,
just this directed heat.
This is not what this is about.